Welcome to VLANs Explained. Today, we're taking that chaotic local area network of yours and transforming it into a highly organized, efficient, and totally secure system. If you've ever battled network congestion or stressed about sensitive data just floating around your entire company, well, you are exactly where you need to be.
Imagine walking into a massive room where every single conversation is happening at maximum volume. Picture your HR department, your sales team, your IT staff, and even the smart thermostats in the break room, all just shouting over each other. They're sharing the exact same network traffic. That means every single device hears every single broadcast. Absolute chaos, right? Massive congestion, and honestly, zero security.
This nightmare scenario, networking pros call it a flat network. In a flat network, all your machines are just lumped together in a single broadcast domain. No partitions, no locked doors, no VIP sections. If one device sends out a broadcast message, literally every other device has to stop, listen, and process it, whether it actually matters to them or not.
So here is our agenda for this explainer. 1. The flat network problem. 2. Enter the virtual LAN. 3. Tags, trunks, and access. 4. Understanding native VLANs. 5. Inter-VLAN routing. And 6. Why VLANs matter today.
Section 1. The flat network problem, or when everyone hears everything.
Think about a growing office. If you've got different departments plugged into one single physical switch, you're faced with a pretty terrible choice. You either suffer through the congestion and the massive security vulnerabilities of a single broadcast domain, where someone in engineering could potentially snoop on payroll data, or you spend an absolute fortune buying separate, dedicated physical switches for every single team. That means more hardware, more cables, and a huge hit to your IT budget.
Moving on to Section 2. Enter the virtual LAN, carving up the switch. A virtual local area network, or VLAN, acts exactly like putting up secure office partitions inside that incredibly loud, chaotic room we talked about earlier. It lets you logically carve up a single physical network switch into distinct, secure areas. You're effectively tricking the hardware into behaving like multiple separate devices. Pretty clever, right? Basically, you're creating isolated virtual mini-switches. You can plug a sales PC into port 1 and an HR PC into port 2 on the exact same physical hardware, and their traffic will never, ever mix. As far as those computers are concerned, they're on entirely different networks in entirely different buildings.
Section 3. Tags, trunks, and access. Directing the traffic.
Now, the absolutely crucial point here is understanding your port types. First, you have access ports. These are for your everyday end devices, like a desktop computer or a printer. These devices don't know what a VLAN is, they just send standard data. So, the switchboard itself is assigned to one single VLAN, let's say VLAN 10 for sales. On the flip side, we have trunk ports. These act as superhighways connecting your switches together. Instead of just carrying traffic for one specific group, a trunk port carries data from multiple VLANs simultaneously, all across a single physical cable.
But wait, how does that trunk superhighway actually keep everything organized? Well, to keep traffic separated as it travels between switches, they use the 802.1q standard. This standard alters the data frame by inserting a specific VLAN ID tag. Think of this tag as a digital keycard attached to the data. When the data arrives at the next switch, that switch checks the keycard, knows exactly which virtual network the data belongs to, and forwards it directly to the correct access ports.
Section 4. Understanding native VLANs, the default lobby.
So this brings up an interesting edge case. If a trunk port is acting as this superhighway that expects every single piece of data to carry a specific 802.1q keycard, what on earth does it do with data that suddenly shows up without one? Maybe from an old hub or a device accidentally plugged directly into the trunk line.
Well, the switch doesn't just drop the data. Instead, it places that untagged data into what is called the native VLAN. You can think of the native VLAN as the default lobby of the network building. Any traffic wandering in without a specific destination tag just gets sent straight to the lobby. By default on most equipment, like Cisco switches for example, this lobby is VLAN 1. And interestingly, when the switch needs to send native VLAN data back out across the trunk, it sends it out completely untagged.
However, configuring this requires strict attention to detail. You absolutely must ensure the native VLAN matches on both connected switches. If switch A thinks the lobby is VLAN 1 and switch B thinks the lobby is VLAN 20, you've got a native VLAN mismatch. Now, protocols like Cisco CDP can warn you about this, but if you leave it broken, you open your network up to dangerous VLAN hopping attacks. That's where a malicious actor can inject traffic into secure network segments they definitely shouldn't have access to.
Section 5. Inter-VLAN routing explained. Bridging the gap.
Okay, so we've successfully isolated our departments. They're safe and secure. But wait, what if HR legitimately needs to send a payroll file over to the sales manager? Because VLANs operate entirely at layer 2 of the OSI model, they are completely isolated broadcast domains. They absolutely cannot communicate with each other directly. I mean, if they could, it would defeat the whole purpose of separating them in the first place. So to bridge the gap, you must introduce a layer 3 device, like a router or a layer 3 switch, which can safely inspect and route the IP packets between the different subnets.
A really popular, highly efficient way to do this is called the router-on-a-stick method. Instead of eating up multiple physical ports on your router for every single VLAN, you just connect the router to the switch using one single trunk link. Then you create virtual subinterfaces on the router. So for example, interface 0.10 for VLAN 10 and 0.20 for VLAN 20. Data from sales travels up the trunk to the router processes it through those virtual interfaces, and then safely routes it back down the trunk to HR. It saves physical ports and keeps routing beautifully organized.
Section 6. Why VLANs matter today. The payoff.
When you step back, VLANs elegantly solve three massive enterprise problems simultaneously. First, segmentation. By breaking up broadcast domains, you eliminate network congestion and drastically improve performance. Second, security. You can easily isolate risky things like internet-connected security cameras or IoT devices, keeping them far, far away from your secure servers. And third, cost. You accomplish all of this logical separation without having to buy dozens of physical switches, which saves tremendous amounts of money and physical rack space.
So take a hard look at your own infrastructure today. Are you running a chaotic, flat network where every device is just yelling over the others and security boundaries are basically non-existent? Or are you ready to harness the power of VLAN tags, trunks, and routing to lock things down and segment your network like a pro? The choice between chaos and control is literally just a configuration away.